Good evening, everyone. I think session till now. We'll wait for 5-10 minutes. Let others join this session as well because today we'll be discussing some as well. I'm going to wait for I guess 5 more minutes. Then we'll start the session for today. No, Kushi, we'll be discussing week 4 assignment today. That will include your Gaussian models and some topics of emission inventories as well. Very few join this class. Okay, so 6:08 by 6:10, I'm going to start the class, and let's see, let others join as per the class proceed. Okay, so shall we start the class? If you guys are there. Hello, am I audible to you guys? Jabin, okay, I don't think so. Anyway, so good evening, everyone. And today we'll be having your weekly tutorial session for week 4. And in this session, we'll be discussing your previous year assignment for the week 4, and we'll be solving the questions that were covered in last year's week 4 assignment. So let's get started. Okay, so first question is this. The Gaussian plume model based estimations of the concentration of a pollutant are not reliable beyond the radius of approximately dash. Okay, so in your class notes, all of you must have like gone through this Gaussian plume model. Basically, it is used to estimate the concentrations of the pollutants and the dispersion. Yeah, I think some issue. Voice is very low. Um, I'm using my headphones, and I think from my side it's fine. Can someone else confirm? Jibin, is that the same issue with you as well? Hello, is this fine? Still my voice is low, or is it fine? If you may confirm, uh, AD, is my voice fine? Hi Harsha, good evening. Mm, okay, so is my voice fine, or is it still very low? Because Harsha, your mic is on, I guess. Hello. Anyway, I think this should be fine. Let me proceed with the class. Okay, so the options are option A 15 kilometers, option B 20 kilometers, option C 25, and option D 30 kilometers. So before proceeding towards the solution of this question, let me just briefly get into this topic, like what is the Gaussian plume model, what are its assumptions and limitations, and some of the advantages, how to calculate the concentration of pollutants. I think I can take this topic very briefly, and that will be a quick revision for you guys as well. So, okay. So, in a Gaussian plume model for the point source, basically, we have three types of sources of pollutants. First one is your point source, second is line source, and third one is your area source. And we can use this plume model for estimating the concentration of pollutants from these sources. at some distances downwind or crosswinds as well. And some of the assumptions are there for this model as well. So initially, basically, what is a point source? Point source is a um, source of pollutant which is like concentrated at a specific point or a space, as we say, it has some specific coordinates. For example, a stack emitting plume of contaminated air, that is an example of a point source. So let us assume that there's this stack here. Let me take this. Okay, so let us assume that there's this stack here, this one, and like for example, assume this stack to be in your Cartesian plane. So there will be three axes passing from this stacks. If we consider this as to be the origin, so if it will be the origin, then there will be one axis. This is your x-axis. Then there will be your y-axis. It is your crosswind distance. X-axis will be your downwind distance, and z-axis. This is your, what do we say, elevation, or this is your z-axis. So, for example, this plume moves upwards. This plume releasing from this moves upward at some height z, delta h, for example, that is your plume rise. This plume moves upwards, it's for some height or delta h, that is your plume rise, and capital H is your height of this stack, and then it starts to like disperse in the ambient environment. So this dispersion of the plume, it is assumed to be as per the Gaussian dispersion. This is the pollution concentration profile. That is the maximum concentration of pollution is assumed to be at the center line of the plume. This dotted line, this is your plume center line, and this follows a Gaussian dispersion pattern. So here axis represents your wind direction, y-axis your y-axis transverse to the wind. This is crosswind distance, and z-axis that passes vertically upwards through the stack. This your z-axis is this. Okay, so what are the parameters that affect the concentration of air pollutant from a point source? There are certain parameters. For example, I think we have taken four parameters that affect the concentration of the air pollutants from a point source. See, this topic is very much important from your examination point of view as well. So please feel free to ask any doubts. You can interrupt me in between as well whenever you feel that your some point is not clear, or you are having any kind of doubt in any topic. Just feel free to stop me then and there and ask your doubt, because this topic is very important. We'll be having numericals from this topic, and as well as some conceptual questions as well in your examination. Can someone tell me that my voice is clear or not? Am I audible? Okay, okay, Harsha, thank you. Okay, so these are the parameters affecting the concentration of air pollutant from a point source. First one is your wind direction. So the transport of the pollutants, that depends very much on the direction of the wind, because what is the direction of the wind at the source height, that will affect your dispersion of the pollutants in the ambient air. The total concentration of the air pollutant is inversely proportional to the increase of wind angle direction, and the direction of plume transport is very important in source impact assessment, because the impact of the source, if the direction of plume transport is like, for example, here it goes towards the right, so the maximum impact that will occur at some point which is towards the right of this stack. And for example, for this stack, the wind direction is towards the left. So the impact will be, the majority of impact will be at some point that is somewhere towards the left of this stack. So the direction of wind affects very much on the source impact assessment. Now second is your wind speed. So for example, generally the speed of the wind increases with the height, and it what it does, it affects the travel time from source to the receptor. For example, it acts as a, like for example, how do we say, it helps in the dispersion of the pollutants. So if the speed of the wind is high, then the travel time from source to the receptor, that reduces. Basically, for example, if the wind speed is twice, then the like travel time will be half. So it is basically directly inversely proportional. The wind speed is inversely proportional to the travel time of the pollutant from this source to this some kind of receptor. And for buoyant sources, like for sources like which are moving upwards, buoyant sources, the plume rise will be affected by the wind speed. Now, next thing is wind speed dilutes continuously with the release pollutants at the point of emission, as explained earlier. If the wind speed is more, the concentration of pollutants get diluted, as you can see from this picture. Here, the concentration of pollutant is very much diluted as compared to this one, where the wind speed is much lower. It is 6 meters per second, and here it is 2 meters per second. So here you can observe the concentration of pollutants is higher as compared to the wind speed, which is more. Now next is your turbulence. Turbulence is your another factor which affects the wind direction and hence the concentration of air pollutants. So it is the highly irregular motion of the wind, and due to this turbulent mixing, the concentration of the pollutants or the dispersion of the pollutants get affected. Now we have some assumptions in the Gaussian plume model. These are assumptions are used for the derivation of the equation of the Gaussian plume model. First one is plume spread results primarily by molecular diffusion. Second is your the time required for the pollutant to travel to the receptor is neglected. That is steady state is assumed. Here we are see we in the Gaussian plume model, basically what we are assuming is the time that is required for the pollutant to travel from the, like for example, if we consider the emissions from a stack, so it will take some time for the pollutants to reach get released from the stack and then reach at certain receptor location. But what do we assume here is the moment the pollutant is released from the stack is the same as it is received at the receptor end. Basically, we are not here. We are not taking into account the impact of like impact of time coordinate. We are just working on the space coordinates and using those in our numerical modeling as well. So that's why this steady state is assumed. We are assuming that there is no variation with time. Then the normal distribution of horizontal and vertical pollutant concentrations in the plume. The pollutant concentrations in the plume are assumed to be normally distributed. Then there is no diffusion in the x direction. And second is the emission rate is uniform and continuous. That is, the emission is continuous. The plume is emitting the pollutants at a uniform rate. The plume is homogeneous. That there's no variation of the concentration of pollutant during the emission. Next is your wind speed is constant. Your terrain is flat, there is no undulations. Second, next, your pollutant dispersion follows normal statistical distribution, earlier told normal distribution. Then the shape of the plume is conical, and the pollutants are non-reactive gases. They do not undergo any reaction or any degradation within themselves. The plume is reflected at the surface with no deposition or reaction with the surface. The point where the plume touches the surface, there is no reaction or any kind of deposition on the surface. It is reflected as it is. So no change in concentration due to this uh, reaction, due to this encounter with the surface. So this is your general equation to calculate the steady state concentration of a contaminant in the ambient air. This is your general equation of the Gaussian plume model. And this equation will vary as per different scenarios. For example, here C is your mean concentration of a substance at a point x, y, z. Whose these are the coordinates of the point where we are getting the concentration. X is your downwind distance, like this distance is your x from the, for example, if this is your stack. X is your downwind distance. Y is your crosswind distance. This distance is your y, crosswind distance. And Z is your vertical distance above the ground. This is your Z. This can be your Z axis. Here Q is contaminant emission rate from the stack, that is given in mass per second. Sigma y is your lateral dispersion coefficient function. This is sigma y and this is sigma z. Sigma z is your vertical dispersion coefficient function. U is the mean wind velocity in downwind direction. And use your mean wind velocity in the downwind direction at a height h. This at this point we are measuring your wind velocity. H is your effective height of stack. Now, for example, there are some simplifications of the Gaussian plume equation under the various conditions. For example, if we have to find out the concentration at the ground level, so this Z will be zero, correct? This Z will be zero. So in the equation, these 2 points where we are having this Z now, these two, these two will become zero. So the equation will be converted into C is equals to Q by this 2 we have taken inwards. So C will be equals to Q by, just a second. I think some students are waiting in the lobby. Okay. So C will be equals to Q by pi u sigma y sigma z exponential of or e raised to power y square upon minus y square by 2 sigma y square. This zero point 0.5 can be taken here as well. It will be 2 sigma y and multiplied by e raised to the power h square upon 2 sigma z square. And if we are taking the concentration at the center line of the plume, then this y will also become 0. So the equation will get converted into just this one. This y will become 0. So q by pi u sigma y sigma z e raised to the power h square by 2 sigma z square. See, looking like this, it's like this can also be written like this now. Q, it is so difficult. This q divided by pi u sigma y sigma z, then your e raised to the power minus h square divided by 2 sigma z square. This is like a simpler looking equation. Instead of writing this point 0.5 0.5, I think you can write this as like this only. Now next is your concentration at the ground level with ground reflection. Here z will be 0, y will be 0, also h will be 0. So source will be at a ground level. For example, we are considering the source of emission. Instead of taking a stack, there will be some source that is at the ground level. Then the concentration will be just q by pi u sigma y sigma z. Now to find the maximum concentration, we'll be finding the concentration at the center line of the plume, and the equation will be 2q sigma z pi u e raised to the power h square sigma y, and sigma z is the distance to the maximum concentration. Now there are some limitations of the Gaussian plume model. It doesn't take into account the time required. For example, what happens is now the assumptions that we take during the derivation of any model, that ultimately becomes its limitations. So we have taken a steady state case assumption, so that is one its limitation, that it does not take into account the time required. Second, it is not well suited for regional modeling of particulates, mostly due to their simplified treatment. Next is it is not able to calculate recirculation effects caused by multiples of buildings at or at intersection, because we are taking the terrain as flat. It is unable to predict concentration beyond radius of approximately 20 kilometers. And the next is for greater distances, wind variations, mixing depths, and the temporal variations become predominant. So that is why we are unable to predict the concentrations beyond the radius of approximately 20 kilometers. So I think this was our question. Let me just quickly get into that. Yeah. So the Gaussian plume model based estimations of the concentration of a pollutant are not reliable beyond the radius of approximately 20 kilometers. I hope this is clear. Now, next is in the downwind direction from an air pollution source, with the increasing distance, the lateral and vertical dispersion coefficients will. Uh, what are these lateral and vertical dispersion coefficients? Can anyone tell me? I've just explained these two terms, the your lateral and vertical, in the equation of the Gaussian term model. What are these lateral and vertical dispersion coefficients? Have a look into this equation and tell me what are these lateral and vertical dispersion coefficients. Anyone?
Sigma Y, Sigma Z.
Correct, Harsha. That is sigma y and sigma z. Sigma y is your lateral dispersion coefficient, and sigma z is your vertical dispersion coefficient. So as we move downwind direction from an air pollution source, so the distance from the source increases. So how do these values change if we increase the distance? So this can be explained with these curves. These are your Pascal Gifford curves to find the values of sigma y and sigma z. So here x is your downward distance. This your horizontal dispersion coefficient. I think this is your horizontal or lateral. This will be your sigma y, and this will be your sigma z. So you can clearly visualize from all these curves that as we move towards the downwind, for example, as this x increases now, the value of sigma y ultimately increases, correct? This value is increasing. Same is the case with your sigma z, that as we move towards downwind direction, your value of sigma z is increasing, isn't it?
Yes, ma'am.
So the answer will be increasing. That is the downwind direction from an impulsion source. With increasing the distance, the lateral and vertical dispersion coefficients will increase. Correct? Now, which of the following is not an example of a line source of air pollution? First is your motor vehicles traveling along a straight section of a highway. Second is agricultural burning along the edge of a field. Third is fire in a large area of a forest. And fourth one is a line of industrial sources on the banks of a river, etc. Okay, so first I think I'll be taking your types of pollutant sources. So during the in the air pollution modeling, we have three kind of sources: your point sources, your area sources, and your line sources. So first, point source. So point source consists of a single emission source with an identified location point at a facility. For example, your chimneys. These are an example of a point source because they have some specific location, and these are single emission sources. Now coming towards the line source. Line source, basically it is a simple emission source that consists of a straight line of finite or infinite length. This line, this is, it can be finite or it can be of infinite length. For example, moving vehicles, that is emission from cars, motorcycles, or trucks. This example I've taken, I think, in my previous class as well, that these are the types of line source emissions. Now, next, your area source. So, area sources are a small emission sources that are widely distributed, but may have substantial cumulative emissions. For example, a cluster of point sources that will act as an area source. For let the one of the common example is open burning or forest fires or the waste incinerators. These act as area sources. So, for our question, motor vehicles traveling along a straight section of a highway. First of all, see what is it is asking is not an example of a line source. So we have to find some source that is not an. This is definitely a source of lines type of line source. Agricultural burning along the edge of a field. This is also some sort of line source. Fire in a large area of a forest. This is area source. This can't be a line source. Then a line of industrial source on the bank of a river. This is also a line source. Now, coming towards the next question. The expression for determination of a concentration C of a pollutant using Gaussian dispersion model for a line source is given as. I think the derivation for this equation is given to you in the class. So I'll just be quickly taking the assumptions for the line source and then the equation. The following assumptions are taken while deriving the expression for concentration of pollutants released from a line source, that is ground level surface, flat terrain as assumed earlier, then infinite length source of ground level. The length of the source is infinite and wind is blowing perpendicular to the line. That is, if this is your line source, then for example, if this is your line source, then the direction of wind will be somewhat like this. This is your wind direction. It is moving perpendicular. So the equation of the Gaussian plume model for line source can be written as C is equals to 2Q. Here Q is the emission rate of from the line source. It will be equals to 2Q divided by root 2 pi sigma z into U. Sigma z is your dispersion coefficient. E raised to the power minus h square by 2 sigma z square. So where it is written as, I think this one. C is equals to 2Q by root 2 pi sigma z u e raised to power minus h square by 2 sigma z square. I think this is the correct answer. Now, I think we'll be taking two numericals of this Gaussian plume model in today's class. So I would prefer if you guys like solve these questions with me parallelly in the same class. So your first question is sulfur dioxide is emitted at a rate of 150 grams per second. Let's highlight the values that are given in the question now. It is emitted at a rate of 150 gram per second. So this will be your Q, correct? From a stack. Stack here, that means it will be of a point source, correct? Point source, emission rate 150 gram per second. This is your Q. With an effective height of 60 meters, this will be your H. The wind speed at stack height is 5 meters per second. This is your U. And the atmospheric stability class is D. This stability class is used during the determination of your sigma y and sigma z, but still these are given in the question only. Sigma y is 38 meters and sigma z is 19 meters. Now ground level concentration along the center line at a distance of 500 meters. Distance is 500 meters. This is your x. Along the center line, that means your y will be equals to 0. In micrograms per cubic meter. So we have marked all the values that are given in the question. No? So given data is C. Sulfur dioxide is emitted at a rate of 150 grams per second. Effective height of stack 60 meters. Wind speed at stack height 5 meters per second. Stability class D. Sigma y 38 meters and sigma z 19 meters. So just putting the values in the question, the equation is C is Q by pi u sigma y sigma z. Since y is 0, to e raised to power h square by 2 sigma z square. Just put the values, put the value of Q as 150, pi into u is 5, sigma y 38, sigma z 19, e raised to power minus 0.5. H is 60 meters stack height divided by sigma z square. So solving this equation, you will get the value as 90.36 into 10 raised to the power minus 6 gram per meter cube. And we have to answer in micrograms per meter cube. So this 10 raised to the power minus 6 ultimately will become micrograms. So 90 micrograms per meter cube will be your ground level concentration at a distance of 500 meters. Any doubt in the question? Anyone, is there anyone who's having any doubt in this numerical?
Ma'am, center line means the y becomes 0, ma'am.
Yeah, true. If you are going to along the center line of the plume, now we have derived this equation as well. I guess here this is concentration along the at the ground level, z is 0, and on the center line y is equals also 0. So this equation we have used because in the question I think they have also mentioned the concentration at the ground level, I guess. Yeah, ground level concentration. This one, ground level concentration. So your Z will also be 0, right? Anyone else? Okay, so we are going towards another numerical. Before
The
taking this, yes,
the stability class D, does it have any special numerical?
yeah, yeah. Actually, if these values of sigma y and sigma z, if these values would not have been given in the question, then this stability class D would have been used. For example, to calculate the value of sigma y and sigma z, you need the stability class. Let me tell you. See, this is your stability class A, B, C, D, E, F. So if the value of sigma y and sigma z have not been given in the question, we have to like estimate at a distance 500 meters downwind, correct? So this is your distance in kilometers. So I think 10 raised to power, this is your 1 kilometers. 500 meters will be somewhere here only. In 1, 2, 3, 4, 5. This point. This is your 500 meters. So to find the value of sigma y and sigma z, we have to use these curves. Like just take a straight line. This is your for your stability class D. Then move like at some point here. So then you'll be getting your values for this sigma y and here some sigma z values as well. So that stability class is used for determination of these sigma y and sigma z values.
Huh.
Okay. So shall we move towards the next question? This is also a numerical question. So if you are having any doubts in the previous question, just ask them because then we'll be solving the next question. I think this is your line source question.
You said that if they didn't give that sigma y, sigma z concentration, we have to use the graph and find the value, no, ma'am.
Yes, true.
And what if we find we couldn't properly if we round off and the number is not close, then the answer will change, ma'am. So how?
So basically, in these type of objective questions, they'll be giving you the values of sigma y and sigma z because they want the answer of all the students to be same. But this type of situation arises where when you're not solving these multiple choice questions. You have just one numerical, and you have to solve and give the answer on your own. Then such situation is there where you have to find the values of sigma y and sigma z, and you'll be getting an approximate answer, not the exact one.
Thank you, ma'am.
Okay. Okay, so shall we move forward towards the next question? What about the
Ma'am,
remaining students? No one is responsive, just joining the class and having nothing. I don't understand. Okay, anyway, your question is estimate the total hydrocarbon concentration at a point 300 meters downwind from an expressway at 5:30 p.m. What does this show? This is your evening time. On an overcast day, the wind is perpendicular to the highway and has a speed of 4 meters per second. The traffic density along the highway is 8,000 vehicles per hour. This is your traffic density, 8,000 vehicles per hour. and the average vehicle speed is 40 miles per hour. The average vehicle emission rate of hydrocarbons is 2 raised to the power 10 to the power minus 2 gram per second. So let's see the emission rate per okay ठीक है. The emission rate per unit length Q is determined from the product of the emission rate per vehicle multiplied by the number of vehicles per unit length. So number of vehicles per meter is given as 8,000 vehicles per hour. This was given in the question, 8,000 vehicles per hour, and average vehicle speed is 40 miles per hour. So what we will be getting here is 8,000 vehicles per hour divided by 40 miles per hour. So this will be vehicles per mile. But what do we need here is vehicles per meter. So I think 1 mile is equals to 1600 meters. So 40 miles will be equals to 1600 40 into 1600 meters. So this will be the value in 0.125 vehicles per meter. Now to find the emission rate, we'll be multiplying this 0.125, that number of vehicles per meter, divided by multiplied by the emission rate of average one vehicle, that is 2 raised into 10 to the power minus 2. So this is your per meter emission rate per meter of the length in grams per second. For an overcast day, it was given that it is an overcast day. So for an overcast day, the stability class is D and the downwind distance X is given as 300 meters. So
What is overcast, ma'am?
just a second. Uh, Overcast basically it means a cloudy day, not a sunny day where the sunshine is not clear. That is your overcast day.
Thank you.
So the stability class will be D. We have a downwind distance X is 300 meters. So this is the value of sigma Z, 12 meters. This is your sigma Z, 12 meters. Just put all the values for the line source. C is 2q divided by root 2 pi sigma Z into U, e raised to power minus h square by 2 sigma Z square. Q is 2.5 into 10 raised to power minus 3. Sigma Z is 12. U is given as 4 meters per second. This is 4 meters per second. So, um, so putting all the values, this will be 42 into 10 raised to power minus 6. It will be equals to 42 micrograms per meter cube. So the total hydrocarbon concentration at a point 300 meter downwind from an expressway is 42 micrograms per meter cube. So now next question. Dash is the product of maximum mixing depth or height and the average wind speed within the mixing layer for a given region. First option A is your ventilation coefficient. Option B is pollutant concentration. Option C is pollution potential. And option D is atmospheric stability. Any idea?
Ventilation coefficient.
Ventilation coefficient. Correct. So basically, your ventilation coefficient is a product of your mixing height Z and the average transport wind speed within the mixing layer, and it is an atmospheric condition which gives an indication of the air pollution dispersion, the ambient air quality, and the pollution potential. So how this ventilation coefficient works? So basically, the higher the coefficient, the more efficiently the atmosphere is able to disperse and dispose the pollutants. And better is the air quality. Basically, your ventilation coefficient is kind of directly related to your air quality. This is your air quality. Please don't confuse this your with your AQI, because that is a different term. This is your air quality. Higher the ventilation coefficient and better is your air quality, and lower ventilation coefficient lead to poor dispersal of pollutants, causing stagnation of and poor air quality, leading to possible pollution-related hazards. Now, towards the next question. Dash of an air environment is the maximum amount of pollution load that can be discharged into it without violating the best designated use of the air resource in the planning region. Option
Assimilative capacity.
correct, assimilative capacity. You must have gone through a topic of assimilative capacity of an airshed. So basically, what is an airshed? Airshed is nothing but a geographical unit having common characteristics of air pollution. So it is kind of similar to a watershed. Uh, Here, like the emission sources, the wind flow patterns, these all will be the same throughout that area, and these similar patterns can be due to similarity in that topography or some meteorological constraints. And it is defined as a part of the atmosphere which behaves in a coherent way with regard to the dispersion of pollutants. The dispersion of the pollutant will be uniform throughout the shed, and it can range from a small area with fewer polluting sources to a large metropolitan agglomeration with complex air quality problems. The area of an airshed can vary. It can be a smaller area to a larger metropolitan city as well. And now, what is assimilative capacity? So, assimilative capacity of an air environment is the maximum amount of pollution load that can be discharged into it without violating the best designated use of the air resource in the planning region. Basically, it is a like it is the maximum pollution load that a particular area or a particular airshed can take. And the phenomena governing the assimilative capacity, these include your dilution, dispersion, and deposition. What is this dilution? Dilution of the pollutants or the dilution of the pollution emitted from the sources, then dispersion of those pollutants, and also deposition in the environment, deposition of the pollutants in the environment. These three factors are responsible for the assimilative capacity of an airshed. And what are the uses of this assimilative capacity? So basically, it is an important tool for suggesting the safe limits of disposal of pollutants. How much pollutants this, nothing like a safe limit. Basically, any type of disposal of pollutant is harmful, but it is just that कि हम कितना अमाउंट ऑफ पॉल्यूशन जो है दैट वी कैन डिस्चार्ज इनटू द एटमॉस्फेयर सो दैट वो एटमॉस्फेयर इजीली उसको एक रेक्टिफाई कर सके. दैट इज योर assimilative capacity. And this leads for the area-based management of air pollution and to mitigate the pollution levels. Then next is your basically your assimilative capacity in broader terms. It is an indicator of potential for future growth. Like to what extent can we use the resources, up to what extent can like the resources can be exploited so that they can be replenished by the nature. So that is one thing that we get from the assimilative capacity. And there are two approaches to find the assimilative capacity of an airshed. First is based on your ventilation coefficient. So the assimilative capacity of the atmosphere is directly proportional to the ventilation coefficient, and this is computed through various meteorological parameters. Your second approach is through pollution control or your dispersion potential, and it is inversely proportional to the pollution potential and directly proportional to the dispersion potential of the atmosphere. And then it is like estimated through your dispersion models. Now, next question. Dash is an average representative value that is related to the quantity of an air pollutant released to the atmosphere due to a particular activity. Your correction factor, activity data, assimilative capacity, and your emission factor.
Emission factor, ma'am.
Emission factor. Okay. I guess. Yeah. Okay, so let's take a quick glimpse of these topics. Your emission inventory. So, is there anyone who can explain what is emission inventory? I think you all must have read this topic in your class.
It is the quantity of all the pollution giving out sources, ma'am. All the vehicles, the industries, the factories, and also the every smoke, dust, everything included is emission inventory.
Okay,
Quantity of everything.
okay. So I think you all must also have read about the source apportionment topic. Okay, so your emission inventory basically it is a record of all the pollution emitting sources for a particular region. As say, for example, if we consider the city of Delhi, so if we try to build up an emission inventory for the city of Delhi, so we'll be including all the sources that are present in that region. For example, the emissions from all the vehicles, the emissions from the industries, the emission from like the waste management facilities, also some kind of construction activities. If it is there, then we'll take that sort of emissions. And also we have a like we have a record of all the activities, and then we have the emission factors of each kind of activity. Then these can be multiplied, and the product gives us the value of those emission inventories, like what how much amount of emission is expected from a certain type of environment or a certain type of activity or a source that is there in the emission inventory. So basically, what is the role of emission inventory? Why do we make such emission inventories? Why it is necessary? So this for the air quality management, the emission inventory can be used for the quantification of actual emissions, like how much emission is there. For the quantification of that data, you can use the emission inventories. Next is your environmental impact assessment. or impact of a certain activity or a certain like area or a certain industry. For for its EIA, we can make emission inventories. Then to develop the policies and to prevent and control emissions. This is for the government, and developing the emission inventories help them to formulate the policies, like what are the prime pollutants that are needed to be focused upon, or what are the prime sources that are needed to be focused upon. Then this can be further used for your modeling activities as well. Then implementation of emission prevention and control measures. Similarly, after the development of policies, these are next is your implementation of those control measures. Next, your emission projections. Like this is some sort of data forecasting in the coming time. What is the trend that is expected to occur at a certain location? This can be visualized from these emission inventories and modeling techniques. Next is your environmental modeling, that is also there for the emission inventory. So these are the common types of pollutants. These are your common types of pollutants that are there in emission inventories. First is your acidifying and ozone precursors. These include SOx, NOx, VOCs, and ammonia. Then your toxic pollutants, which are PM2.5, PM10, carbon monoxide, black carbon, and total suspended particulates. Then your organics, PHs, PCB, pesticides, greenhouse gases, CO2, methane, N2O, hydrofluorocarbons, PFCs, SF6, and then your heavy metals. These all are the common pollutants that are included in emission inventories. So the basic equation for the estimation of your emissions. So for any kind of source, the emissions total emission will be equals to the emission factor multiplied by the activity data. So what are these emission factors? Emission factors are the average rate of emission of a pollutant per unit of the activity data, and the activity data gives us a measure of the scale of activity that causes the emissions. Okay, so next coming towards your activity data. Your activity data includes, like for example, transport activity, like, which further includes your category of vehicle, type of fuel, and quantity of those vehicles. Then your crematorium, some spatial locations and number of cases that come each day, because there are some emissions from those crematoriums as well. Then your power plant, type of technology, which kind of power plant is there? Is it a like hydrothermal power plant, or is it some thermal power plant, or is it some nuclear power plant? Anything. Waste burning, like for quantity per capita, the amount of waste generated per capita, how much waste is burnt each day, that is your activity data. Then for the biomedical waste, the quantity of waste generated per day. Then for the diesel generator, the how much amount of fuel is used, and for how much time the generator is used. So that this is the basically this is the sort of activity data for different type of sources that is collected to find the emission of the air pollutants. Then your emission factor. So there are some standards that have been set, or some manuals that are given for the emission factor of different type of sources. So what is an emission factor? It is a representative value that attempts to relate the quantity of air pollutant released in the atmosphere due to a particular activity associated. And these emission factors, basically these are expressed as a mass of pollutant per unit of volume or weight of the raw material. So when these two are multiplied, then we have the total emission from a specific type of sources. Next the basic equation for estimating the emission from a particular section is given as the product of first is your activity data and emission factor, second is your activity data and concentration of a pollutant, third is emission factor and average wind speed, and fourth is emission factor and concentration of a pollutant. So what will
Activity
be
emission factor.
activity data and emission factor just taken earlier in the previous slide? The total emission from a source is the multiplication of your emission factor and the activity data. So with this, I think I've taken your questions till week 4. If you guys are having any kind of doubt or any question regarding the topics that are discussed in today's class, you can ask. Or if you are having any doubt in like this year's assignment that are being given to you, any question that is not getting solved or any kind of doubt that you're having, you can also ask those as well. No doubts, nothing.
What is the difference between emissions inventory and emission factor?
Okay, see, emission inventory is the record of the total emission from a certain pollutant source. It gives us the total amount of emission from a particular source. That is your emission inventory. And not just one particular source, basically, it is a record of all the pollution sources within a certain environment. For example, if you consider a city or a specific locality or a township or anything, so it is for that for a specific time period for that particular area, all the pollution emitting sources which were present at that point, उनसे कितना amount of pollution generate हो रहा है, that is your emission inventory. And emission factor, that is for one particular source, कि per unit mass अगर हम कोई पार्टिकल कोई भी पॉल्यूटेंट बर्न कर रहे हैं और एनीथिंग लाइक दैट, तो वो एक रिप्रेजेंटेटिव फ्रैक्शन है जिसको हम उस एक्टिविटी से अगर मल्टीप्लाई करते हैं, देन विल गेट द टोटल अमाउंट ऑफ एमिशंस. So that is the difference between the emission factor and the emission inventories. Inventory is some sort of record or the like inventory. For example, inventory is what? Nothing. Just say, for example, consider if we have a shop or a go down. So keeping record of all the stock that is present there, that is also one sort of inventory. So keeping record of all sort of emissions for a specific time and specific space, that is your emission inventory.
Thank you.
Welcome.
Ma'am, in air quality index, there are separate indexes for NO2, SO2, and we have certain values for that, ma'am. So there are a lot of tables to remember. So how can we keep it in our mind, ma'am? Because for the numericals, they are asking the value of air quality index of certain pollutants, ma'am. So should we remember all the tables, ma'am?
Um, See, it's basically it's practically, I guess it's impossible to remember all the values. But what you can have is just you can have a basic idea about the values, like or the general standards. For example, for the AQI, it is very easy to remember, correct? The AQI values you can remember, like what is in good, what is in moderate, what is like uh, getting my point. But for the type of pollutants, I guess it will come with time when you read it again and again now. So it's possible that you get idea of some pollutants or some of the other pollutants. It's just a sort of practice, and I don't think it's possible to remember each and every value because nobody remembers those values. With time, if you study ना, आप बार बार चीज़ों को रिकॉल करोगे, देन इट्स पॉसिबल दैट कि हाँ ठीक है अभी एक आइडिया हो जाएगा कि कौन सी वैल्यूज हैं. अदरवाइज इट्स वेरी डिफिकल्ट टू हैव एन आइडिया. आई डोंट थिंक इतना इजीली पॉसिबल है.
Yes, ma'am. Thank you, ma'am.
Nobody else is having any kind of doubt, any kind of query or any question. Everyone is so smart and like knows everything. Or he's, I don't know.
So this is the table I was asking about. How can,
Yeah, this table now.
ma'am?
See, some values are relatable. For example, the value of ozone. I guess initially it's almost the same as your AQI or your PM. Your PM10 is almost same as your AQI category. Just a slight variation is there. See, these ranges ना ये almost similar है like 0 to 50 or 0 to 30 or 0 to 40. What you have to keep in mind is these values. For example, this carbon monoxide. इसकी वैल्यू बहुत कम है as compared to the other values. It's 0 to 1, 1.1 to 2. It's very much different as compared to these values. Or the value of lead. तो इसका emissions बहुत कम है. And this, for example, this ammonia. तो इसकी वैल्यूज हम काफी हायर अमाउंट में भी परमिसिबल है. सो these are the points that you have to keep in mind कि कौन सी वैल्यूज अप्रॉक्स एक आइडिया होना चाहिए कि कहाँ तक परमिसिबल है. Otherwise it's like practically it's not possible, or like if it is possible then it will take a lot of time to remember all these values. Anyone else? Any other question?
Amongst agriculture sources, industry sources, and vehicular sources, which is most polluting and polluting in India?
Okay. Amongst agricultural, vehicular and industrial, right? See, Harsha, what happens is now, it depends on the site that we are considering, because I guess as far as air pollution levels are considered, agricultural emissions doesn't contribute much unless and until that is agricultural burning is there, like the sort of soot burning, like parali that is being burnt in the Haryana region. So that contributes a lot in the air pollution. But apart from that, there are not much emissions from the agricultural sector. Then your industries, they tend to contribute a lot. For example, like if you consider your scenario for the Delhi now, so there are a lot of vehicles in that region and also a lot of industries as well. So both tend to have an significant impact on the air pollution levels. And agricultural emissions, basically they are like seasonal emissions, but these industrial and vehicular emissions, they are constant. Basically these are occurring throughout the year. So the major difference is that only कि agricultural emissions जो होते हैं वो for a certain amount of time पर होते हैं.
Thank you, ma'am.
Anyone else? Any numerical or any topic that you want to discuss?
Is Gaussian flow model very important, ma'am? You said in the starting it is very important. There are many.
Yeah, yeah, there are many models, but as far as till now, what as far as numerical modeling techniques are considered now, rest of the models basically more, they are more sort of computational models. We use some softwares to do that, and this is something that still we are using this technique for numerical modeling approaches. And this is a very general or the very basic model to find the concentration of any sort of air pollutant. So that is why it is very important as far as your whether it is from your exam point of view or from your this course content, you will be getting, I think, some questions, one or two questions definitely you will be getting from this Gaussian flow model, or maybe more than that as well.
So in the end, there will be 75 questions. So how many will be from numericals, ma'am?
Right now, I don't have basically any idea about how many questions will be numerical, but definitely there will be some mixed sort of questions. You will be having numericals as well as theoretical questions. I think by the end of this lectures, or by the end of this session, like when we will reach up to week 10th or week 12th, then we'll be able to gauge the like variation of numerical as well as theoretical questions, because once all the topics are covered now, then you can judge what are the important topics that numericals will be asked from. Roughly giving any idea, like you can have a numerical from Gaussian models, you can have numericals from emission inventories, and then your source apportionment studies. Then initially for like emissions or gaseous pollutant, some numericals can be from there as well. Then I guess what are the other topics for the numerical? I think for numerical purposes, then yeah, for some questions will be from your air pollution control devices as well. Some numerical questions might be asked from that portion as well.
Yes, ma'am. Thank you, ma'am. And so the other models are computational, or we use the computer uh, to predict those models. So, uh, will will you show us any video like how to use those models, ma'am?
Yeah, definitely we can like have some videos for those models. Right now, I think there's some one model called Air Mod. So that also includes, but that is basically for mostly for ambient air concentrations. So that one model is there, but for like as far as video is considered, I think several videos are available online also, and I don't think that much is needed in this class only, because you just have to have a brief idea about all sort of models, and which model is used for the prediction of which sort of pollutant, and rest I think for as far as this course is considered, that much is sufficient. You don't have to use your computational techniques or any type sort of softwares for this course.
Yes, ma'am. Thank you. The major topics in our air pollution control course is air quality index, ma'am, and air quality modeling, ma'am, and then source apportionment, ma'am. So, what are the major areas of our course, ma'am?
Major areas. See, I think every topic is important, but if you are asking about the major areas that I guess these air quality modeling, these air quality models, then starting if we get from starting, then these sources and effects of the air pollution, then I guess your social apportionment studies, and indoor air pollution, that is a very easy and theoretical kind of topic, but yeah, you need to have a brief idea about that as well. And in the last, I guess your like control devices, these are the major areas that are there. And apart from that, rest everything is like you can have a brief idea. I think those are the theoretical topics, so you need to know about them just in case any question comes from that part.
Yes, ma'am. In the beginning, they have given the history of the policies they have, the internationally they have devised, and there are so many dates, and so should we memorize that also?
See, I can't clearly say that you should memorize or not. Basically, see, practically, if you can remember, then it's so far so good. Otherwise, like you need to have an idea about those events and episodes or the policies. Some are the important policies, like the when this Air Pollution Act came in account, and some other acts as well. But apart from that, it just you'll be having, I think, one or two questions from that section. So it's like practically feasible that you can leave that portion as well. Just have a brief idea about that part.
Yes, ma'am. Thank you. sink and receptor are the same thing, ma'am. So source and sink
Sink
are back.
and the yeah, sink and the receptor are one and the same things. Right.
Thank you.
So Harsha, what do you do basically? Where you from and what's your branch?
I can't hear properly.
I was asking like where are you from and what do you do? Are you a student or research scholar?
Ma'am, I am doing MSc Environmental Science from Indira Gandhi National Open University, ma'am. From,
Okay.
so I have taken this course for project, ma'am, fourth semester. So I thought I'll do something. I asked you, ma'am, and you gave me that idea of doing air quality modeling, ma'am. So
Yeah, yeah. Okay, okay. Got it. So, students, are you able to solve the numericals that have been given in your class, or you're having any difficulty in those numerical sessions?
and sometimes we are able to solve. Sometimes we are getting confused because the terms are very technical also.
Okay, so then what do you guys do? Like, how do you solve those questions for like your tutorial sessions that you're having these this week or the previous weeks?
Ma'am, first we look at the example the sir has given in the PPT, ma'am. Then we read it two to three times, and then we go to the problem, and then we try to solve.
Okay. So you can do one thing also from the next class onwards now. If you're having like any doubt in the tutorial session and any question for the current year session, you can share your doubts here as well. So since we have this class for 2 hours and the questions that we discuss, I think they are for like 1.5 hours or like 1 hour 15 minutes, not more than that. So what we can do is we can have a this kind of discussion session after this class now. Like if we have to take a class of 2 hours, what's the point in just spending the time and not using that? So you can share your doubts or any kind of questions that you want to discuss in this class only, and we can take that. It will be a learning for the remaining students as well.
Ma'am, ma'am, so how to actually stay? I'm taking all the PPTs and writing them all in a note, ma'am. So if I go in that place, so is it enough, or how can you please suggest me how to read, go through the course, ma'am?
How to go through the course? Okay. So I think as far as the like NPTEL syllabus is considered, the presentations are very detailed. So I think that much is sufficient for you. But still, if you want to go through some textbooks, then you can have a look one at one textbook that is PV Row, that is good for your environmental engineering. And I think apart from that, uh, there's no need to refer to any textbook because the presentations in itself are very much detailed. So just to prepare the notes now, just write down those topics and have a some explanation about those topics, and try to practice some numericals from the internet as well, because I think what's mm, the point that is missing here na, ki we don't have much numericals in these presentations. So for that thing I think you can refer your online sources if you want to practice some numericals. Other than that, I think for the theoretical portion the presentations in itself are enough. You don't need to like go through much content apart from this.
Yes, ma'am. Thank you, ma'am. There is a term called as aerosol optical depth, ma'am. It says aerosol optical depth expresses the quantity of light removed from a beam by scattering of aerosols during its path through the atmosphere. So I can't understand.
Can you please share the uh, presentation where this topic has been discussed? Aerosol optical depth, right? Just let me know about the which lecture we have discussed this aerosol optical depth. Um, Harsha?
Ma'am, I'm just once again. Ma'am,
Okay, okay, sure.
I think it's 25th lecture, ma'am. 25th lecture.
25th. Okay, just a second. Let me just open that lecture and then I'll see. 25th lecture. Twenty-fifth, application of remote sensing or satellite data in air quality management. This one?
Ma'am,
Okay. What was the topic you said? Optic particle depth. What was that? Harsha, can you please repeat the topic that you asked?
Ma'am, dash expresses the quantity of light removed from a beam by, sorry, ma'am, aerosol optical depth, ma'am.
Aerosol optical depth, right? Okay. Concentration. Okay, this is aerosol optical depth. Got it. Basically,
Should I share the screen, ma'am?
I got that. I got that. So basically, the aerosol optical depth, what it is ना कि ये जो amount of light है, for example, ये होती है to use the to predict the amount of the particulate matter that is present in the atmosphere. तो हाउ डू वी डू दैट ना कि हम एक अमाउंट ऑफ सर्टेन अमाउंट ऑफ लाइट है जो कि दैट इज गेटिंग आइदर scattered or absorbed. So the light that is getting scattered or absorbed, this is due to the presence of those particulates in the atmosphere. So scattering or absorption ये aerosol की presence में होगा. This is clear, right? So the quantity of light that is removed, the quantity of light that is removed, this is directly related to those number of particles, right? So ये जो amount of light है that is being removed either by scattering or by absorption due to the presence of aerosols, this amount of light, that this is termed as your optical depth. Got it? This amount of light that is getting removed either by the scattering or by absorption due to the presence of aerosols, and that is why this aerosol optical depth this is used for the prediction of your particulate emissions in the atmosphere. For the presence of particulates, I think this is directly related. It is directly proportional. The amount of particulates which are present in the atmosphere, these are directly proportional to your aerosol optical depth.
Thank you.
Any other topic? Okay, so I guess if you guys are not having any doubts, we can end this session now.
Ma'am.
Okay, so see you guys next week, same time. Take care.
Thank
Bye
you,
bye.
ma'am.
See you.